Hi, in this video we want to talk about 3D problems. So trigonometry but in 3D. What we've done so far has mostly been in 2D where we're discussing solving for an angle or solving for an unknown side of a certain triangle. But now we're taking it into a dimension that adds more layers basically. So in 3D space. We're visualizing buildings, we're visualizing terrains. All all of these things have something to do with right angle triangles and some with just triangles in general. So we are gonna have a lesson, or you might have already watched the lesson on triangles, but that lesson will speak about the different triangles and their properties. But we've also already at this point gone through the laws or the rules that we can use to find unknown sides and unknown angles, even for non-right angle triangles. So here's just an example that I just took out of a past paper. Basically, we are trying to simplify, we're trying to investigate, determine the distance of AB in terms of h. So you always be given this long scenario. It's important to read it, definitely. So that's what we're going to start by doing. A pilot is flying in a helicopter at point A, which at point A, which is h meters directly above point D. So directly above point D shows us that it's a straight line. He notices a strange object at point B, which is there. The pilot determines that the angle of depression from A to B is 30 degrees. So we see that expressed. He also determines that the control room at point C is 3 meters away from A. So we see that also expressed here. And BAC is equals to 2x. That is also expressed over there. Points BC and D are in the same horizontal plane. This scenario is shown in the diagram below. So this is a very important point. B, C, and D are in the same horizontal plane. Stating this allows us to visualize this as a right angle triangle that is not on any incline, and therefore we can use the values as they are. So the first question says determine the distance AB in terms of h. So how can we represent AB in terms of h? Well, we already have h. If we redraw this triangle, which is something that usually helps, redrawing the plane that triangle is in, we see that this is A, that is B, and that can be considered D or C depending on how you're looking at it, but that's point D. Then this height over here, AD is H, and we are also told that the angle of depression from A to B is 30 degrees. Therefore, that means that this is 60 degrees because this is a 90-degree angle. Now, we can write AB in terms of h by saying that by using a trig function that relates the side that is adjacent to the angle and the hypotenuse, which is what we're looking for, AB. So adjacent of hypotenuse, that would be car or cos. Cos is equal to adjacent, which is h, over hypotenuse, which is AB. Multiply both sides by AB, and this is not just cos but cos 60 degrees. So that would be cos 60 degrees is equal to h over AB. AB is equals to h over cos 60 if you simplify it fully. Then this is our answer. And then 7.2 says show that the distance between the strange object at point B and the control room at point C is given by the following formula. So now we are told that we have to prove that BC is equal to h square root of 25 minus 24 cos square x. Now my intention is not to actually solve these questions, but just give you the knowledge and the steps that you can check yourself with as you progress along with these types of problems. So it's important to note what is in this formula. So we see that we have 25 and 24. Is there any 25 or 24 that we see on the diagram? Nope. We see cos square x. Do we see any cos square x over here? No, but we see a 2x over here. And what they're asking us to express in terms of h is BC, which is this side of the triangle. So it's definitely got something to do with this 2x over here, this 3h over here, and this AB that we just got, which is h over cos 60. And although I know that you're not watching these videos in preparation for your NSC exams, rather for your NBTs, so I'm just going to give this hint, which is for NSC exams, that these questions are often leading. Anything that you calculate prior to the difficult question, you basically have to use in order to get this answer. So the answer that we just got, we're going to have to apply it to get that BC. But in terms of NBTs, it won't be this simple because each and every question is independent. Rarely do we ever have two questions that use the same diagram. But in this case, we now have to solve for BC. So this 7.2 alone is a question that could be found in the NBTs. Of course, they wouldn't say that, show that it is this, but they would say derive an expression for BC in terms of x and h. So how do we determine an expression for BC in terms of h and x? We use a rule that allows us to express BC in terms of the sides and the angle. And in this case, we've already gone through the rules. There's the cos rule and the sine rule. The sine rule requires that we at least have two angles if we want to express a side. But the cos rule only requires two sides and one angle. Therefore, by applying the rule, a squared is equals to b squared plus c squared minus 2bc times cos of a, we can figure this out. Where a is this side and b is that and c is that, so a, small letter a, will be this side opposite the angle. This would be small letter c, this would be small letter b. So all you have to do is make your substitutions and then take the square root at the end, and then you will have your problem simplified. And that's about it for 3D problems.